Okay, now moving ahead with the Surds topic, what do we see in here? There is this express 98 in the form of a root b, where a and b are integers and a is greater than 1. So 98 is the number that is given to me, right? So when the number 98 is given, what do you have to do? You have to go with prime factorization. You have to use prime numbers to find the factors of that particular number. So 2, it is an even number, it goes with 2 times table. 2 4s are 8, and the remaining one goes on the top of 8. This becomes an 18 now. So what do you do for 18? 2 9s are 18, and then 49 comes in 7 times table. 7 7s are 49 and 7 1s are, okay, because this number was given in a root 98. What do? You make the pairs of it, okay. The pairs will be written out, and then the single term will be written inside the root, okay. So 7 root 2 would be the answer. So here your a is 7 and b is 2, because he gave it in the form of a root b. So this is your a and this is your b. This is your b, this is your a, is what you get here. Next is show that 6 minus 8 root square is equal to this much. Show you're working clearly. Each stage should be shown in here. Now here 6 minus root 8, there are two ways to do it. Whole square. There, the first one is using the identity. And what is the identity? A minus b whole square is equal to a square minus 2ab plus b square is the identity. What is your a? This is your a and this is your b. So let's just write it down. A square is 6 square minus 2. A is 6 into b. B is root 8. Okay. Plus b square, that is root 8 whole square, comes here. Okay. Then root 6 square is 36 minus 2 6 are 8, 12. 12 root 8 would come here. And then the square root and the square, they cancel each other. Okay. They cancel each other and we are left with a plus 8. So here we have the 36 plus 8, it becomes, that is equal to 6 is 14, 44 minus 12 root 8 is the answer. Okay, 12 root 8 is the answer that we get here. But 8 can be split up and written as 2 cube. That means if I want to write 8, I can write it like this. 8 can be written as 8 is equal to root of 2 times 2 times 2. So the pairs should be taken out as a single term and then 2 will be left inside. So here it becomes 44 minus 12 into, in place of 8 we will write 2 root 2, 2 root 2. That becomes 44 minus 12 2s are 24. Root 2 would be the answer. That is what they wanted us to show, and here it is that we have. Okay. Now, this is one way of doing it. Another way of doing it is writing the 6 minus root 8 whole square is what you have. What does that mean? Like we mean x square is equal to x times of x. The same way, 6 minus root 8, okay, times of 6 minus root 8 is what I have. Okay, now each term multiplies with the other term. 6 multiplies with 6, 36. Then 6 multiplies with it, minus 6 root 8 it becomes. Then this multiplies with this, it becomes minus 6 root 8. And then root 8 into root 8, minus into minus, plus root 8 into root 8 is 8. Okay, now this and this will add together, that becomes 44. And then these both will add together, minus 12 root 8. Till here you get the same term, and then after which root 8 can be written as 2 root 2. Root 8 is equal to 2 root 2 is what I have. So it will be written 44 minus 12 times of 2 root 2, that is equal to 44 minus 24 root 2 is what you get. Okay. Moving with the next question in here, rationalize the denominator and simplify fully. You have to rationalize the denominator. Rationalizing the denominator is multiply and divide with the opposite sign of the denominator. It's a plus here. So you're going to multiply and divide with a negative sign in here. 4 minus root 5 is what you have. So here, simple multiplication. 33 multiplies with each term in here. So 33 times of 4 is 1, 2, 1, 13, 132 minus 33 root 5 over, we have 4 plus root 5 times of 4 minus root 5. That is in the form of a square minus b square. Okay, we have just used this identity on the first question of the previous worksheet. So a plus b, wherever you have, times of a minus b, it becomes a square minus b square. So 4 square minus root 5 whole square is what we have. Now that becomes 132 minus 33 root 5, okay, over 4 square is 16 minus 5. That turns out to be 16 minus 5 is 9. 132 minus 33 root 5. Is there anything that you can take common out of here? I think we can take 3 common out. Okay, so 132, let's divide with 3 and see, or we can just do this, not like this. 132 divided by 3 we are checking because we want to cancel it like that. Okay, so 3 ones are 3 fours are 44s are, yes. Okay, so we can take the 3 common out from here. Let the 9 be here. Let's take 3 common out. That becomes 44 minus 11 root 5 over 3 over 9, sorry. Then 9 goes with 3 times table and this goes once, so you are left with 44 minus 11 root 5 over 3. There are 2 ways to leave your answer. You can leave your answer here or you can leave your answer here. They both are the same answers. The last one is a simplified, furthermore simplified version of it. Okay, so what we did in the rationalization, we took the same term but with a different sign, okay, and we started to simplify it. Multiplying and dividing with the denominator is what we have done here. Okay, now moving ahead with the next one. Again, the same type of question is given. Write your answer. The clear working is to be depicted in here. You have to show their clear working. So 7 minus root 5 is given to us here and 2 plus root 5. So rationalizing the denominator. In Surds, this is a condition. In mathematics, this is a condition. And what is the condition? The condition is that we are not required to show the root part in the denominator. Okay, the denominator should be free of the root part is what we are supposed to pay attention to. Okay, so that's what exactly we are doing here. Okay, so what is it? 7 minus root 5. I will just write down the term in here. It becomes 7. It becomes 7 minus root 5 over 2 plus root 5 is what I have. Now this is going to multiply with the denominator. So 2 minus root 5 and 2 minus root 5 goes here. Okay, so what do we get? Each term multiplies with the other. 7 multiplies with it. It becomes 2 sevens are 14, and then 7 multiplies with 5. That becomes minus 7 root 5. Okay, then 5 multiplies with 2. It becomes minus 2 root 5, and then this root multiplies with the 5 term, so it becomes minus into minus plus. Root 5 into 5 is 5. Okay, root 5 into root 5 is 5. So there is this thing, root a terms of root a is equal to a. So here root 5 times of root 5 is equal to 5, not 25. Okay, then in the denominator it is in the form of a plus b times of a minus b, which is equal to a square minus b square. So a square is 2 square minus root 5 whole square it goes. Then this square root and the square gets cancelled. We are left with 4 minus 5 in the denominator. 4 minus 5 in the denominator, and numerator 14 and 5, they will add together. That becomes a 19, and this becomes 9 root 5 is what I am left with. So here the denominator would be minus 1. 19 minus 9 root 5. We'll not leave a minus in the denominator. We bring it to the top. So it becomes, when we bring it to the top, minus 19. Sorry, this is what it becomes, and then this minus multiplies with each term here, so that becomes minus 19 plus 9 root 5, and rearrange the terms. Another rule in mathematics, we don't want to start the answer with a negative term, so we write it as 9 root 5 plus 19. And then they asked, what is your a and b term is this is your, sorry, there's supposed to be a minus here, minus 19. This is your b root 5 and this is your a. So your a is 19. minus 19 is your a. Pay attention, not just 19 but minus 19, because we have to pay attention to the sign also. So a is equal to minus 19 and b is equal to 9 is what you get from here. Okay, next question. Root of 48 plus 108, root 108 can be expressed in terms of this, where a and b are integers. Again, root terms of prime factorization, you go with 2 2s are 4s are, then 2 times 1s are 2s are, then 2 6s are, then 2 3s are, then 3 1s are is what you're left with. Okay, now I have 108 again, 2 times 2 5s are 4 times 2 2 times 7 times 3 3 times 9 times, sorry, 9 times, and then 3 times, and then 3 1 times is what you get. So make the pairs in here. This is one pair, this is one pair. So you get for 48, root 48 can be written as root of 48. When we write it down, we get 2 times 2 root 3 is what you get. And over here, what do you get? Root 2 root 3. Okay, so you get root of 108, sorry, root of 108 turns out to be 2 times root of, no, 2 times 3 times of root 3 is what you get. So that becomes 4 root 3 here, and this becomes 6 root 3. So you have 4 root 3, where did this pencil go? 4 root 3 plus 6 root 3 is what you have. That becomes 10 root 3. So they asked, it is in the form of a root b. So this is my a, this is my b. So a is equal to 10 and b is equal to 3 is what you will write here. Okay, now these are quite simple questions if you know the trick of how you can solve these questions. Okay, now moving ahead to the next question that we have, and it goes as, show that 5 minus root 12 and 6 minus root 3 is equal to so and so forth. Show each stage of your working. Okay, so what do we do here? Okay, now the terms are given to you. So what is that we are going to do? We are required to do the multiplication of this and get this answer and show the working for this one. Okay, so fine, first 5 multiplies with this, it becomes 30, and then we have 5 multiplies with this, that becomes 5 root 3, and then this multiplies with it becomes 6 root 12, negative 6 root 12, and then minus 12 into minus 3, that becomes minus root 36. Okay, fine. Now here there is, before I press, no, let's complete this question in here. It becomes 30 minus 5 root 3 remains as it is. Now 12 can be written as 2 root 3. 2 root 3, I'm saying that 12 can be written as 2 root 3. How does that happen? 12 is equal to 4 times of 3. So if it is under the root, then the root of 4 is 2 and 3 remains under the root itself. So minus 6, and instead of 12, we are going to write it as 2 root 3 in here. Okay, then minus 36. 36 root is 6 itself. Okay, then this term and this term will, sorry, this is going to be plus minus and minus, right? Yeah, this term and this term will add together, that becomes 36, and then minus 5 and minus 12 root 3 minus 5 root 3 minus 12 root 3 is there here. So that becomes 36 minus 17 root 3 would be the answer. That's exactly what they asked us to show. Now here there is a catch. When I have a root a plus root b, I cannot add them together. It is not possible to do a plus b in here. Instead, what do I do then? If I have root a and I have plus root, let's take an example of root 3. We have root 3 plus root 2, then it is not at all possible to make root 5. Nope, 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 it remains as it is. But if I have 4 root 3 and 6 root 3, then I can add them and it becomes 10 root 3. If the roots are same, if the root part of a number is same, of two numbers are same, then you can add them. Okay, then you can multiply. We said that addition of roots is not possible, but multiplication of roots is possible. Root a into root b is equal to root ab, it becomes. Okay, so that means root 3 times of root 2 can become root 6. This is very much possible, but this is not at all possible as what we see. It remains as root 3 plus root 2 only, it will remain as. Okay, that is what the end of the Surds part is about.